Hello everybody, welcome back to my channel. Today we're going to talk about relational operations. This is a certain type of logical operations when you want to know if something is true or if it's false. To put an example, let's start with number relations. The If I run the eighth line, we know that 4 is indeed less than 6. So this is a true statement. When I run this line over here, R returns a true value. If I run that 4 is greater than 6, which we know is not true, then we get a false value. If I want to assign a value to a with a certain name in my working space, let's say I want to a equal to 2, and we can run this line over here to see whether a is actually equal to 2. And the equal relational operation is called by two consecutive equal signs. We get this is a true statement and this is a false statement. And to put the different signs, we use the exclamation mark followed by the equal sign. We run this line over here and we get that this is a false statement. Um, you may also compare two vectors. So let's say that you want to know whether a vector is greater than another vector. And what this will do is that it will compare entry 1 for the first vector to entry 1 of the second vector. And it will do that operation for all the entries. So the result is a vector of true and false that gives me if the corresponding entry of the first vector is greater than the corresponding entry of the second vector. If I run this line over here, I'll get just the opposite result. And this is how it works. This is quite useful when we are working with databases. Um, but you could also do this and run this matrix over here. And A is a 2-row and 3-column matrix. If we want to know which entries of the matrix are less than 5, I run this line over here and I will get a matrix of true and false, which gives me which of the entries are actually greater than 5 and which are not. An important part of logical operations is Boolean algebra. A Boolean algebra is basically an operation that you might do with logical values, and R understands the true and false as numerical values. If I run this line over here, and as numeric function is a function that we have used in a different video, if I run this line over here, I'll see that R is understanding true as number 1. If I run this line over here, I'll get that false is equal to 0. This is how R understands these two values. And equivalently, I can run this line. This is a statement that we have already evaluated in the first line that I ran. And if I put the statement in the numeric function, I'll get that this is a 1 because it is true. And this will be a 0 because it is false. Boolean algebra allows you to operate different logical values. For example, let's say that you want to evaluate this operation over here. You know that 4 is actually less than 6, this is true, and 1 is less than 2, this is also true. What happens if I add these two up? I will get a 2 because each one of these arguments is a 1 according to how R is interpreting these results. But if I run this complete line over here, I will read that 2 as a logical value. And this is true. And it is true because both arguments that I'm adding up are true. Something that is true plus something that is also true is true. That's the reason. What if I ran this over here, and this is the thing that I did two pieces of code above. If I run this here, I will get that this is a 2. This is an arithmetic operation. What if I run this here? This is just putting this line inside the as numeric function. This is a 1, and this is a 1 because this whole operation is true. That's the main differences between Boolean operation and arithmetic operation. Boolean operations only accepts zeros and ones whether something is true or whether something is false, and this is how it works. And the Boolean operations in R are quite useful when we are working with matrices and databases. We have already done this before. Recall that A is a matrix, is a 2-row, 3-column matrix. If I run this line here, I will extract the second column. If I run this line over here, I will ask R which of the entries of the second column of A are less than 4. I get that the first element is not less than 4, and the second element is less than 4. That's what this result tells me. If I put this operation, this logical operation, this complete logical operation, in the row space of A, I will just subset the matrix. And subsetting the matrix means that I will get, as a result, all the rows of A which this condition is provided. Let's run this line. I will get just one vector, 5, 3, and 8. Let's run A for a moment, and let's see what is going on here. As we can see, the 5, 3, and 8 vector that we are getting is this second line over here. And the reason for that is because I have just told R to return all the columns such that the second all the columns such that the second column, the row corresponding to the second column, is less than 4, and this is only true for the second column, the second row. Sorry, the first row has no value greater than 4. This is how it works. And let's say that you have a 1 times 12 vector here. This is a vector, quite a large vector actually, and you want to know which one of the entries of the vector are less than 6, and we get the result. If we count the map, we will see that there are 9 true values. If I run this line here, I'm actually telling R to sum up all of those true values. Recall that each true value is a 1 and each false value is a 0. So by telling to add this statement over here, what I'm doing is adding up 1 9 times and 0 the rest 3 times. That's the reason why the result is 9, which is actually the number of true values of the vector. Another important topic here is how R understands missing values. A missing value is called by the NA statement. There is an actual function that is called the is.na, which tells me whether something is missing or whether something is not missing. This function returns a logical value. That's the main important part of this. If I run this line here, this is quite common. Sometimes you have a database where certain column has no value for a certain row. So let's run this here. y has some embedded NA values, 3 in total. If I run this line here, I will ask R which one of the entries of the vector have NA. And I get that the second, and 3, 4, 5, the 6th, 7, 8, 9, and the 10th, the last one. If I run this line here, recall that the exclamation mark is actually the way R negates a statement. If I run this here, I will get the opposite result. And if I run this line over here, I'm actually asking R to add up how many values of y, of the vector y, are not missing. And I get that 7. 7 of them are not missing. So I hope this was really useful. So I hope to see you in the next video.